Hey, welcome to the shop. Today, with the use of Movie Magic, I am filming over the weekend in my garage. So today, we're going to be talking about testing of a lighting circuit. I'm going to be using a 2008 Freightliner FDL as my example truck. Now, the first thing you want to do is you want to obtain the driver's manual for your appropriate truck. The reason for this is that the driver's manual is going to contain the list of loads that will be on that particular circuit that you're testing, and you want to have that list so that you can go through each of the checks that I'll be talking about today. Now, step one in checking a lighting circuit is you want to test the battery voltage, because the battery voltage is going to be your reference voltage. It's going to tell you how much voltage is being applied to each of the loads. The next step you want to check is the voltage between your battery and your fuse box. And you want to check each leg of the voltage. So you want to check the positive and the negative, and you want to do the drop across the fuse. After you've done that, you want to move on to checking the load on the particular lights. Now first, before we get into actually checking the load, we are going to be talking about how to properly probe the circuit in order to do the check. So one of the things that you want to do is you want to use T-pins. That's what's pictured here. Now these T-pins, they're smaller than the probe, and you're going to be putting them in a specific way, in a specific way that'll allow you to do the check without damaging the wires. When most people talk about probing the wires, the one thing you don't want to do is take your probe and shove it into the wire, because you could damage the wiring, you could damage the insulation, and you'll basically be creating a fault in that wire that can be a future hazard for you, or a potential fault. So you want to use T-pins. The other thing that you want to do is when you're probing, you want to make sure that you're probing from exposed parts, or you're probing from the plug. So what I have here, right here in the video, is demonstrated. You're probing from behind. So you're taking the T-pins, you're putting it in behind the plug, and you're placing each one in. Now, before you do this, you want to reference your manual and locating what the proper wire is for each of the testing. So you want to know what your common wire is, what your signal wire is, and what your voltage wire is. That way you'll know for each one. After you've properly probed and placed your T-pins, then you're going to move on to actually testing the circuit. Now, when starting to test the circuit, the method for doing this is, first you're going to want to test each leg of the circuit. So you're going to want to test positive from the positive wire to the positive on your battery, as shown here. So positive to positive. Then you're going to go negative to negative. You're going to go to the common wire, and you're going to touch it to the negative. Even though the common wire isn't always hooked to the negative, most of the time the common wire goes into the ECM, and that's where your negative is used through. But you're going to go negative to negative. Then your next step is to drop across the load. So pictured here will show dropping across the load. So this is going to be from the common wire to your voltage. This will give you your voltage drop across that load. Now you want to do each of these for each item listed in your circuit. So when you reference the manual and it shows each load that's attached to that circuit, you want to do your drop across each of those. Now there's the long way where you can drop each leg of that particular circuit, but that's for school purposes. If you're out in the shop, you're going to target specific problem areas, things that have thrown up codes or lights that are not acting appropriately. that's where you're going to do your testing. So as I said, you're going to be doing positive to positive, negative to negative, and you're going to be dropping across the load. Now you also want to make sure you understand how much voltage is being used. And for instance, when you're dropping positive to positive, if you're showing like 80 millivolts, you're not getting enough voltage to light that light, or you may get a dim light. Same across the negative. Now when you're doing this testing across the from positive to positive or negative to negative, that's going to show you which leg you're having the trouble on. If you're showing really few millivolts on the positive, you're going to see that there may be high resistance. If you're showing nothing, you're going to have a break in the line. So from there, you're going to be able to go on using Ohm's law in order to calculate the voltage and whatnot. If there's a break in the line, and you find out there's high resistance or whatnot, you're going to be able to use a tracer. The tracer unit is a small unit that you'll attach at each end of the line, and it'll basically put out an RF signal, and you'll use another device to trace over the line, and it'll read that RF signal. Once it gets to the high resistance or break, there'll be a change in that signal, and it'll notify you. So there you can determine where in your harness the break is or the high resistance, and you can make your repairs appropriately, either by if the damage is a high amount of damage to several wires, you may have to replace the harness. If it's done to a specific wire, you may be able to either replace the whole wire or just cut out that one piece and solder in a new section. Now soldering isn't going to be the best connection, but depending on how they want it done, it may be cheap, it may be easy, it may be now, and it'll get you back out on the road. But soldering is a fix, and if you know how to solder and do it correctly, you could probably make just as strong of a connection as if it was just one whole wire. So one of the other things you want to look for is when you're testing the positive or the negative. Now there's a certain allowance as far as the drop. Now on a positive leg, you don't want to drop more than half a volt. So if there's more than a half a volt drop, then you have a high amount of resistance. If you're testing the negative leg, you're looking about 2/10. If you have anything more than 2/10, you're looking at a high resistance. So after you've properly probed and checked the circuit for each leg of the drop, compared it to the basic numbers on if it's half a volt on the positive side or 2/10 on the negative side, you've traced the lines looking for any problems. That then puts you into the point where you then have to fix the problem, and then from there you'll want to do your test again to double check everything that you've done. So thanks for joining me for this video. In the next video that I'll be doing, we're going to be going over testing of sensors and smaller components, and the video after that will be making repairs on those electrical components. Yeah.